Hello everyone, welcome to the Aerovision classes, and today is our lecture 2. In the last class we discussed still potential energy of the particular small masses due to the capital mass. Now let us hunt for the kinetic energy. So let me tell you something which is related to upcoming topics. Let's suppose there is a mass m, which is capital mass or heavier body you can say, and let's suppose there is a small mass which is rotating around this capital body, right? Like our sun and moon. You can assume like this is your earth and this is your moon. So we know that moon is a moving or rotating around this particular body, that is our earth. So this moon is having some acceleration, right? Because if it is moving, it must be some acceleration, it must be some velocity, right? It is having some potential energy, it is having some kinetic energy, because see, we have already derived the acceleration of a small mass due to this capital mass, right, in our previous class. Then after in future we'll derive the velocity for the two different things, for circular orbit as well as the elliptical orbit, right? This mass is having some potential energy because it is having some height, like here, from here to here distance is r. So let's suppose this is your earth surface, then from here to here this is your h, that is your height. So it is having some potential energy, because potential energy is nothing but your mgh. Of course mass is there, gravity is there, like gravity due to acceleration due to gravity, as well as h is there because it is height only, right? So it must be there. How this kinetic energy is there? Because you know, half mv square, mass is there, right? A small mass, velocity is there here, so it will be kinetic energy also. At the same time, this mass can go into two things, like see, if it is having the velocity, so this velocity can be resolved in two parts, that is in theta direction and in radial direction. So in upcoming topics we'll study the for this theta or for this radial direction, velocity in radial direction, velocity in tangential direction. So that time I will explain you what is this v theta and vr. So as of now we have completed the acceleration and potential energy. Now let's hunt for the kinetic energy, right? So I'm not erasing this because it will be help for some time. So write new topic, that is kinetic energy. So let me write in wordings. Let's suppose now consider kinetic energy here need to stabilize our coordinate system. More precisely the polar coordinates. I will tell you guys what are the polar coordinates. Let me finish the wordings, because when you understand the things and if it is written in the wording, so it will be very clear when you revise in the upcoming days, like after 10 days, 20 days, 30 days, or 1 month, 2 months. So if the wordings are written in your notes, then it will be clear. Otherwise by figure you can't understand everything, right? So precisely for the polar coordinates, in this case This is very useful. So now let me tell you what is polar coordinates. So let me bring back to you childhood. So we have studied in our childhood or up to 11th or 12th standard coordinate system, right? Coordinate system. There are basically three types of coordinate system exist till now, right? As far we have discovered. So first is our Cartesian coordinate. Cartesian coordinate, or you can say also rectangular coordinates. Then second one is your polar coordinates. And the third and very tough is spherical coordinates. So in our childhood, you used to study the x, y, or z axis like this, right? So everything comes in a Cartesian coordinates, right? Like your x, y, and z. So everything is in the Cartesian coordinates. But in polar coordinates, there's something called r and theta. What are these r and theta? This r is nothing but your radial distance or you can say radius, right? This theta is your angle. It can be in radians or degrees also. Sometimes it degrees, sometimes it radians, but mostly radians. Okay. Then this spherical coordinates, something called r, theta, and something is called phi. But we are very lucky that we should not study this physical coordinates in our GATE syllabus. GATE syllabus is only about the Cartesian coordinates as well as the polar coordinates. More precisely, Cartesian coordinates. We study the polar coordinates for different things, and questions also come for the polar coordinates also. But mostly the questions are coming within this. Whether it is mathematics, aerodynamics, propulsion, everything, mostly questions come from this. But there must be questions regarding the polar coordinates also. So you must study the polar coordinates too, right? Okay. Let me do one thing. Okay, so then let me tell you how to convert radians into degrees. So remember, pi c is equal to 180 degree. Always remember this, pi c is equal to 180. This is in radians. This is in degrees. Right? If the questions will come, I will tell you in very nice way how to convert degree into radians and vice versa. Okay, so till here it's completed. Okay, so now let me draw a figure to understand this kinetic energy. Okay, draw a figure neatly, guys, because if figures are neat, then it will be very helpful to understand the things very clearly. Okay, this mass is small m. So this is your capital mass, this is your small mass, some plus centroid. We have to join the centroid of these two masses with radius r. Okay, So now guys, pay attention. This at some angle, because we are considering the polar coordinate, so there must be some angle. Now pay attention. This mass is revolving around this capital mass, right? So this mass is having some velocity, right? Let's suppose it is having some velocity v. Then in our 12th standard or 11th standard, we have studied that for resolving the forces, resolving the any properties, like let's suppose if your force is like this at some angle, then we can resolve these forces in two parts, F cos theta and F sin theta. So where we are resolving this force into component in sin theta and cos theta, right? So at the same time we will resolve this velocity into components, that is your VR, and another one is your V theta. Let me tell you what is this VR and V theta. So right here better. So this VR is your radial component of velocity, or you can say the radial velocity. This BR is nothing but your dr by dt, which is nothing but your r dot. Okay, that means what it means actually, this r is changing with respect to time. That means this radius is changing with respect to time. Okay, so whenever you find the dot or cap, not cap, dot of any properties, that means that particular properties is getting differentiation with respect to the time. So whenever you see the s dot, t dot, or something, any properties dot, so that property is divided by the dt. That means you might have studied in your intermediate, so you know. Okay, then let me tell what is the then b theta. Let me tell this one. Okay, then b theta is nothing but your tangential circumferential azimuthal and periphery. Guys, please make your own notes. Whatever I'm writing on my screen, I'm saying that because of my handwriting, so I'm saying clearly, please write in your notes. Please make your notes clearly, or whatever I'm saying extra thing, please note in some in your notes in some side, because it will help when you revise, because I'm saying it with my experience. Periphery velocity. So why I'm writing the four names? Actually, is all are the same thing. What does the examiner do? If they want to ask the tangential velocity, they might have asked circumferential velocity, they might have asked azimuthal velocity, they can ask peripheral velocity. So all these names are the same. So you have to remember all these names, because the questions can come by any names. So if you remember only tangential, if the question will come from this, so you will lose the marks, and these things are the pocket marks basically. So now what is this b theta? B theta is nothing but d theta by dt, similar to the dr by dt. And one thing I'm saying, you will please pay attention, whenever the theta come, we have to multiply with r. Guys, this I will tell you when I will teach you the aerodynamics and mathematics, because if I will explain here, so you will not understand this much. So that is why, as of now, please remember this. Whenever there is theta, the r will come into the picture, and there is some, like unit cancellation is there. So I will tell you when I will teach you mathematics, and this can be also written as r into theta dot. So this is your, basically, this b theta and this br is nothing but is given by this and br. Now you tell me, what is velocity then? Velocity is square is equal to vr square plus b theta square. Is it right? Because if you are resolving the component, so the addition square of the particular component will be added together, and that will equal to the original component. So you can write also v is equal to under root vr square plus b theta square, right? So you will get your value of velocity. Then now find the kinetic energy. So the kinetic energy is given by with mass m, right? We are talking about the mass m, that is why I am writing mass m. That is, kinetic energy is equal to half m b square, right? You can replace this on the place of v, so half m vr square plus b theta square. Similarly, you can say this kinetic energy is equal to half m r dot square plus r theta dot square. This is your formula for kinetic energy. This is equation number 6. I think the last one is a 5, right? Yeah. This is your equation number 6. Now we have found the 3 things till now: the kinetic energy, potential energy, and the acceleration, right? Okay, now let me tell you something very interesting. The equations of the motion in this particular radial direction as well as the tangential direction. So we have to find the equation of motion in these 2 directions. So for that, we have to write equation of motion. So write a new topic: equation of motion. So the equation of motion for the space dynamics we generally or we usually use something is called Lagrangian function. Lagrangian function. This is nothing but your difference of kinetic energy and potential energy, right? See, so this is denoted by L. So what is Lagrangian function? So L is equal to the difference of kinetic energy minus potential energy, right? Which is, and in our see, the kinetic energy is denoted. Let's denote with some some kind of notation. It will be very helpful. It is denoted as T, and this potential energy is denoted as a phi. It is denoted as a phi. So it will be very helpful when you will write the equations in very simple way in form of T and phi. So it will be very simple. Okay, so it will be your T minus phi. Then what will be the equations or Lagrangian equations? So L is equal to half m v square. V is nothing but your r dot square plus r theta dot square. Here is a plus minus, right? This is your potential energy. The phi is your potential energy. I'm writing here because so the formula for potential energy is minus G capital M small m divided by R. So this minus and minus will become plus, okay, and the capital G small m or capital M divided by the R. This becomes your Lagrangian equation, right? Lagrangian function, basically equation of motion. Now we have to basically what we are doing is we have to find the equations of motion in this direction, in tangential direction, like in like in radial direction, as well as the, you can see, okay, let me take another color. Okay, in radial direction as well as the tangential direction, we have to find the equation of motion. That is why we are building our basics so that we can derive this. Now you write the new topic, that is your not new topic, extension of this topic, Lagrangian equation for each coordinates. See, let's suppose this qi is your coordinates. Let us suppose this is your coordinate. Then what Lagrangian function basically can be written as d by dt of dou of Lagrangian function, that is this, divided by the dou of qi dot, I'm saying dot, okay, minus dou L by dou qi. Pay attention, is here is a qi dot, that means the coordinates will be a dot and this will be a coordinate. There is nothing called dot over here. So in the same case we are looking for the radial and tangential. So in r direction, that means here in r direction, or you can say the radial direction, it can be written as d by dt of dou L by dou r dot minus dou L by dou r, right? Similarly for this theta direction, that is your tangential direction, d by dt of dou L by dou theta dot minus dou L by dou theta, right? These are the Lagrangian equations for the each coordinate, that is your coordinates for the different direction, that is your radial direction and that is your tangential direction. Now let me, that is equal to 0, actually, sorry, I forgot this, that is equal to 0. So it must be equal to 0, it will be equal to 0. Now let us hunt for the equation of motion, because see what I'm doing now. Actually, I told you, if this mass is rotating, if this mass is going in radial direction, so this mass is having some, like motion, because it is moving, so there must be some motion, there must be some acceleration, velocity, or something, because it is mass, so there is something motion. Similarly, in the tangential direction, this mass is having some motion, so that's what we are going to find this, or that's what we are going to find for this radial and tangential direction. So now write a new topic, that is equation of motion in tangential direction. First, let's see tangential direction. Okay, now let's start. So we know that dy dt of dou L by dou theta dot minus dou L by dou theta is equal to 0. Fine. So we have to write this. So dy dt of dou by dou theta dot, you have to write the whole L, this L, right? This L is nothing but your this one. So we have to write. So let me copy. So I'm placing this here, right? The same thing. Okay, 2 is okay. This is minus, again same thing, half mv square, half m dot something. Okay, I'm writing here, or we can say like you can reduce this. So this will be your dou by dou theta of particular of this, not this, right, is equal to 0. So when we will differentiate it, you will come to know that you differentiate by your own, because you know differentiation. When you differentiate with respect to the thetas dot and theta, so you'll come to know that d by d2 of m r square theta dot is equal to 0. This is your equation number. Let's see. This is equation number. Let's suppose it was your 6. Then this is your 7. Okay. This is your 6. This is your 7. Then this is your, okay, this is your 8. That's why I'm writing the equation number, because when you will complete your, like your whole syllabus, you will come to know that there are almost 2000 formulas. So this is my habit to write the formulas, equations with numbers. So this is your equation number 9. Now let's discuss this. It's very it's very wonderful thing. What we can write this m square mr square theta dot. We can split this, right? m r theta dot. So what is this r and theta dot? This is basically what? Let's see. This is basically b theta. We can have some here from here, right? b theta is your r theta dot, right? So we can write this mr b theta. That is why d by dt of mr b theta. Guys, this mr b theta is called as the angular momentum. Angular momentum. This is called as the angular momentum. So there are forms. It can be mr square theta dot, okay? It can be mr r theta dot, or it can be mr b theta. These all things are called angular momentum. These all things are called angular momentum. See, so now it is equal to 0 because from here. So if you know from your basic, if derivative of anything, if it comes equal to 0, that means there must be any constant, because derivative of constants can only be 0, right? If there is some constant, so derivative of this constant will be 0. If we are taking some derivative of the variable, so it will be your 5. It will not 0 because here it will be variable. So you know the derivative of the constant is always be 0. So if here is a 0, that means whatever our functions are there within this derivative, so it must be some constant, right? It must be some constant. So that is why this mr b theta is your constant, right? So this is called your p, that is equal to m r b theta is your constant. And what is this? This is your angular momentum, as I told earlier. Angular momentum, guys, it's momentum. In 2022, the question has come from here. It was MSQ question, multiple selective questions. There are 2-3 options more, but one of the options are this, in which case angular momentum is constant something. They asked. When I will practice the questions for you, then I will let you know what are the questions, how to solve, and what they have asked actually. So this is your angular momentum. So that means what you can write from here, keywords. From here you can write this. Okay, let me write again for you. D by dt of mr b theta, if it is 0, that means whenever t is in the denominator, that means the rate, that means the derivative in this with respect to the derivative, the derivative is with respect to the time, that means that is called rate. So whenever you see the d theta in the denominator, then it is called rate. So the rate of change, basically it is called rate of change, because d means derivative is change. The rate of change of angular momentum is shunya, that means is 0. Okay, so please pay attention. They can ask in the future questions like in which case the rate of change of angular momentum is 0. They might have give options like, let me take one get questions, not get questions, let me guess one get questions. In which case, write a question, in which case the rate of change of angular momentum is 0. The options are given: equation of motion in tangential direction. Option B is given in radial direction. Non. And suppose the other question is, like if they can give angular momentum constant. Is constant. So what is the answer? So if you remember this key, we are driving this angular momentum is constant or rate of change of angular momentum is 0, in which case if you are driving from this equation of motion in tangential direction. So if you remember this, then you can take your own 1 marks. So the option is first, that is your equation of motion in tangential direction. Understand? So they can ask questions like this 1 mark question. So you have to remember so that the angular momentum is constant or the rate of change of angular momentum is 0, in which case it is coming. So it is coming in from equation of motion in tangential direction. Okay. Now write the very useful term I'm writing here. Let's see. Let H is angular momentum per unit mass. This is one of the notation we are going to use throughout this chapter, that angular momentum per unit mass is denoted as a H. So basically it is also a constant, because it is also a constant, right? Because it is also a constant. So what is this now actually? So H is nothing but your angular momentum. What is angular momentum? M R B theta or M R square theta dot, is it? Or so what they are saying is angular momentum, that is angular momentum per unit mass. That means per unit mass. So mass is getting cancelled. Okay. So you will have H is equal to R B theta R square theta, which is basically a constant. The question can come from this only. Can be also come from this. Okay, what is angular momentum per unit mass? So it might be a constant, of course. Now write for the equation of motion in radial direction. As we have derived equation of motion in tangential direction, the same way we have to derive equation of motion in radial direction. I told you why we are deriving this. So write equation of motion in radial direction. Guys, this is basically very long derivation actually. So I'm writing the final part. Please you follow some book for space dynamics for getting the derivation. Actually, although the derivations are not important, but you should know the steps from where it is coming, and you should know to explain by yourself how these things are coming. Because if you know this, if you know the steps of this particular thing, then you can answer these types of questions. So I'm skipping the derivation for this particular thing. Please use any reference for this particular thing for derive your equation of motion in a radial action. The final part I'm writing is, which gives us the very interesting thing, that is your R is equal to P divided by 1 plus E cos theta minus C. This is very important equation, guys. I'll tell you what are the things. This is called, okay, let me take this equation number your 10. Okay, 10. This is your equation number 10. This is called equation of a conic, or it is also called the orbit equation. I'll tell you something about this orbit equation. So see, what is this basically equation means? Let's suppose your rocket is going into the space like this. So what the trajectory this rocket will follow, this is decided by this equation actually, and basically this is decided by this E. E is nothing but your eccentricity. Okay, I will discuss this E. This E is nothing but your eccentricity. Okay, so whatever paths are following for any rocket, for your Chandrayaan 3, Chandrayaan 2, Chandrayaan 1, Gaganyaan, every missions for every country, NASA, ISRO, like from Russia, everywhere, if the rockets are going into the space or into the deep space, to the moon, to the Mars, anywhere, if they are leaving the Earth's surface, so what trajectory they are going to follow, that trajectory is decided by this equation only. So keep in this mind. Okay, this is very important question, guys. So write, then after I will write something. Fine. The above equation is called conic equation, or equation of conic. It is applicable to the trajectory of a space vehicle in orbit. And escaping from the gravitational field of Earth, as well as artificial satellite. Artificial satellite in orbit. Above the Earth. So guys, if the rockets are going to launch from Earth's surface, and if it is going to stabilize in some orbit or in satellite or somewhere it is going, and it is moving from the Earth and it is escaping from the Earth, so these are the equations which are being used for this particular trajectory. Fine. So let me tell you what are these things. So here r is your distance. Okay, see, this is very important. Let's suppose this is your Earth surface, like it is your Earth, and this is some kind of small m. Okay, this is your r. So up to here, from here to here, this is your radius of Earth. Suppose this is Earth and this is Moon. So up to from here to here, this is your radius of Earth, and from here to here is your height. This will be given in the question. So whenever you write the r, so you must have see whether the radius of the Earth is given or height is given or not. If the height is given, so you have to add the re plus h. If height is not given, then you have to write this r is equal to the re only, right? Radius of the Earth. Fine. Then this e is your eccentricity. Fine. Now let me take you one thing, that is, what is this p actually means? This p is nothing but your k divided by, this p is nothing but your h divided by k square. I will tell you what the k and h. Okay, then r okay, p okay, e okay, theta is angle, c is the path angle, c is your path angle, not path angle, is phase angle, you can say, or phase angle. Then theta is your angle. Now let me tell you one or two things very important. What is this k? Okay, till here. Okay, right here I'm giving you some constant values for the things. We have to remember always. With although it will give in the question, but if it is not given into the question, you have to write your own. So what is mass of Earth? It's ma. This is basically, okay, let me take, that will be mass of Earth. It is 5.972 into 10 to the power 26. It is actually, I'm taking exactly. What is g? G is your gravitational constant, which is nothing but your 6.67 into 10 to the power minus 11. Okay, now what is this k? What is this k square? K square is nothing but the multiplication of these two, g m e, which is coming as 3.986 into 10 to the power 14. Okay, and these things I have told already. Yeah, fine. So everything is written in this. You have to remember this table always. You have to remember this. It's very important, guys. When I'm saying important, then it is very important. Fine. Now let me take this equation again. Okay, till here completed. Fine, 50 minutes is done. Okay, then let me take other 20 minutes. Okay, now we write one new topic, that is your space vehicle trajectory. So as equations has come for this basically for trajectory, that is r is equal to p divided by 1 plus e cos theta minus c, right? Theta minus c. Now this eccentricity can be, if this eccentricity is equal to 0, okay, this is your eccentricity of a conic, you can say eccentricity of a conic, because this is called conic equation, that is why eccentricity of a conic. If the E is 0, then this is called the circle. That means the trajectory is going to follow, that will be a circular trajectory if E is 0. If E is equal to 1, then the trajectory by the space vehicles are going to follow the parabolic. If E is greater than 1, then trajectory by the vehicles which is going to follow will be the hyperbolic. And similarly, if the eccentricity of the conic is less than 1, that will be your the elliptic orbit. So guys, the questions majorly come from here: circular orbit as well as the elliptic orbit. And basically we mostly deals about the circular orbit as well as the elliptic orbit, because when we want to travel into the deep space, like Uranus or Neptune or type of planet, if you want to visit, so it is something called the deep space. But we are not going to this. We are only sticking to the parabolic and circular and elliptic. So mostly this is the basically these two are the important. So whatever we are going to derive in the future, the velocity, the escape velocity, or whatever the things we are going to derive for this elliptic as well as the circular, right? So now you draw one very neatly figure what you can expect by cutting a space cone. Now let's see. Okay, let me take another one. Draw very neatly figure, guys. Okay, let me draw this very neatly. Okay, there is something called a space cone. So what will happen if this space cone is cut by this, by this, by this, by this, by any plane, by any plane types of thing? This is called a space cone. First of all, so you might have seen every time, like this is your past, or past something, this is your present, or something. In the Stephen Hawking books, it is mentioned very nicely. So let's see what happens. This is your axis, of course. Fine. Now see, if you cut this cone by at angle this, by this, if you cut this cone by this, by at some angle, so what will be, let's see, this will be your ellipse. Basically, this will be your ellipse. The size will be same by the cutting, but it's okay, you can understand. This will be your ellipse. If you cut the cone by the horizontal like this, so this becomes your circle. This becomes a circle. So if you cut this cone by the slant of this cone, so you will get the ellipse. And if you cut this if you cut this cone by at some angle, you will get this ellipse. And if you cut this ellipse cone at horizontally, you will get circle. Now what happens if I cut this cone by this particular thing, slant, and as well as base? So if you cut this, so what will you get? Let's see. If you cut this, so you will get some kind of hyperbola. Some kind of hyperbola. This is your ellipse, sorry, circle. And if you cut this cone by at some angle with the base and the slant, so you will get the parabola. Parabola. Right. So these are the things. It's not that much important, although I have told you, because it will be very clear to you in your mind. Like, you can say dumbbell type. If you take the dumbbell and if you cut by the same thing, you will get the same thing whatever I have written on my screen. Now, okay, so it's already 1 hour. Okay, then let me stop here. We'll continue from next class. So till now, I think it's very clear that if you understand this figure, so very neatly you can remember all those things, what are the things is required to find the things in your stress dynamics, because everything is based on this small mass, like velocity, acceleration and all that. So I have told you everything over here very neatly. Then we have done kinetic energy, equation of motion, Lagrangian function equations, then this momentum equations, like not momentum equation, angular momentum constant, rate of change of angular momentum 0, everything. Then we did one question very easy, the equation of delta x, and then the most important equation for the conic or space trajectory, that is 0, that is 0 given by this. Then we have done eccentricity, like then we did cone type. So till here I think it's clear. So let me stop now here. If you follow this lecture very neatly and very clearly, and see till here nothing is important. I'll tell you important question from where the importance are basically the questions are basically come. Basically the questions are coming into the GATE exam. From which part that is coming, I'll tell you within the 1 or 2 lecture. So now we are actually going to start the things which are basically coming into the exams, like velocities, intercircular or elliptic something like Kepler's law, everything. So this is our basics. The questions are coming from here also, but it might be 1 mark. So no one is going to ask you what is d by dt of mr square theta dot, and what is this like what is Lagrangian function, what is Lagrangian equations. No one is going to ask, but still you have to remember all this formula, because it might come in 1 mark. No one knows what can they ask. They can ask anything, they can ask anything. Most of the time they have asked these equations, like what are the conic equation or trajectory equation or equation of conic. So they give the options of like this, and 4 options you have to select one right option. So there are lots of questions regarding this. When I will practice the question, and when I'll do the PYQs, I will tell you the basic approach and how to solve the questions very clearly and very neatly. So prepare well. Till now whatever I'm teaching you, this is enough for the space dynamics. Nothing is required for the practicing the problems or questions. Whatever I'm teaching, this is enough. When I'll do the problems, I will do all the PYQs, because space dynamics is little bit very tricky when they want to give the tough questions. So they will give tough questions and no one is going to solve, because everyone is studying this basics thing. So basically if they want to trap you, they can give tough questions. If they want to but mostly in space dynamics the questions usually come very easy. You can solve, you can take your 2 or 3 marks in your pocket if you have a good practice whatever I'm teaching you, or whatever I'm giving you assignments. So please keep practicing and keep revising everything. Whatever you don't understand, please feel free to ask in the comment section, and we'll discuss in the comment section and next class. So please revise and do the well, and let's start and crack the GATE exam with me. Thank you so much for your patience with me and supporting me. So thank you so much guys. Have a good day, and I'm making the videos in night, so good night to all, and thank you so much. Let's meet in the next class.